where they do a gel electrophoresis with DNA this time. So remember, they did the practice one with the dye. Now they get to do the real thing. And once they know that everything's gone well and that we have that RFP in place in our plasmid, then they'll use that plasmid that they made in those first couple of labs to do that bacterial transformation that I mentioned earlier, where they'll use the plasmid they just made to transform bacteria, transform some E. coli, so that they express this RFP protein. Now, they can also go on from here to say, okay, I want to really make sure that that's not just that crazy pink bathroom fungus growing on my plate or some other weird pink thing that just decided to show up. So they can do a PCR and they can confirm that, yes, indeed, that red that we're seeing, that fluorescence that we're seeing is from the RFP gene, just like we thought. They can also culture one of those colonies, or you never can culture one colony, right? Culture one of those little spots on the plate, and they can isolate it and they can purify the protein and get a little vial of hot pink protein. Now you might say, okay, that's nice, but they're playing around with a protein that's not particularly useful. The entire curriculum is actually built through a storyline where red fluorescent protein is being used as a stand-in for making insulin, because these are the basic steps that you would use to create, not to create insulin, but to make insulin. Instead of extracting it from the pancreas of some poor pig that you slaughtered, you're going to actually make it in a bacteria. So this is exactly the process that's used to make insulin for patients who need it now. So they have this storyline of diabetes, which all of our students are familiar with in one way or another, unfortunately. So they can understand that, oh, okay, I can see why we would want to take a gene out of one organism, put it into another organism and make big batches of it. I can see it in a medical context that I'm going to be familiar with on one way or another. But when I'm actually doing the labs, instead of making insulin, which is going to be a clear fluid that turns into a clear fluid and you can't really see anything, they have this nice pink, literally hot pink reference point, so they can have a nice visual saying, yes, you were successful, you did all the steps right, and look at this hot pink protein that you got in the end. If you were doing this in a medical lab, you would have gotten insulin and you would be able to help somebody with diabetes. Next slide, please. There's a whole host of resources in the student guide for the students. You can see just one snippet of a page over there with our 2 plasmids that they start with at the bottom. It's a nice way to lay things out for the students. So you go through this diabetes and insulin production storyline, and along the way, we've got very clear learning goals. We've got great visuals. So this isn't the greatest example of the beautiful art, but we have a lot of really great art. You can see it's nicely laid out. It's easy to follow. There's embedded literacy strategies. The analysis questions are actually relevant to the labs, and they're the kinds of questions students have to think about to answer, not just look quickly for the answer on the page or look it up on Google. There's glossaries provided. The curriculum is also available in multiple languages. So there's a lot of good resources for the students in the student guide. There's also, next slide, a comprehensive teacher guide. There's a choice of lab sequences, which I'll go through in a second. There's really detailed prep information. It identifies different media resources that you can use. It gives timing for the activities, supplemental activities if you have more time to go deeper into the different subjects. It even gives, this is one of my favorites for new teachers or teachers who are new to teaching biotech, it even gives specific questions to encourage student discourse. So if you are brand new to this and you're like, oh, what did Lauren say in training? I don't remember what's going on here. The teacher's guide will actually walk you through it step by step. And then of course, there's things like lab safety information and other helpful tips that you want available at your fingertips. There's tips at your fingertips. Next slide, please. I mentioned a couple of times the different sequences. This is how they fall. The sequences are in the columns that you're seeing in front of you. So you can see the 6 labs on the left, or 7 labs technically. If you do the complete series, as I mentioned, you go through all the labs I just talked through, but you can also opt to do something called an abridged genetic engineering sequence, which instead of building their own plasmid, the students are going to take a plasmid that already has that RFP ligated into it. It's also been purified and supercoiled, so it's a nice power punch of plasmid instead of when they make their own, you tend to get, you've got other conformations and some other things going on there. It's the nature of the lab. With the abridged, it's a very straightforward, it's nice, especially if somebody's teaching a general bio class, or they want to teach it, say, let's say you're one of those lucky teachers like I was, who gets a 9th grade bio class, and the kids are doing this at the beginning of the year when they're still a little bit squirrely. Not that teenagers aren't ever squirrely, but they're still a little bit squirrely in that first couple of weeks in 9th grade. This can be a nice way to walk them through it. The complete genetic engineering sequence is often more done in biotech classes, or maybe AP bio classes, if they have a little bit more time, or slightly older students who have maybe had a chance to work with some of the techniques before. A lot of biology teachers also opt to do the Focus on Bacteria series, which is just the skills practice at the beginning, and then they go straight into the transformation, occasionally followed by protein purification. But in my experience, mostly if they're doing Focus on Bacteria, they just do those 2 quick labs. And we do have the option to do just that intro lab. Oftentimes I see this in schools where they're articulating really well in the grade bands, and they want a chance for their freshmen who are in maybe a general science class to do something before they get to bio. I've had middle school teachers who want to teach the biotech, but they know they've got to take it really easy with their middle school students. They'll sometimes do the intro to biotech, and that just gets their hands on some of the equipment and gives them a chance to do real science without taking the time to do the full sequence. So it's really nicely laid out. I was a high school teacher myself, and now when I'm not doing ABE, so 70% of my job is to develop curriculum. So I feel like I can say with authority, this is a great curriculum. It's really well laid out. My teachers rave about it. They're really, really happy with it. And I serve about 80 teachers a year. And I've had minimal complaints. You never get no complaints, but I've had minimal complaints. Everybody loves this. They think it's really great. And they love the experience for their students. We're constantly getting really, really good feedback on the experience that the students have. And I believe that's my last slide. Karen, are there any questions at this point? It seems like it might be a good time to see if anybody needs to ask anything of myself or Lauren.
Yes, actually, there is a question. And it is, how can we contact you about these programs and bringing them into our schools?
You have to be patient and wait for the end of the session when we'll put all of our contact information on a slide for you. So it will be there for all 3 of us. So you can contact us regardless of which geographic location you're in.
Okay, that was our only question thus far. So.
Okay, I'll hand it over to Jo then.
Okay, thank you. So as you've heard, the Amgen Biotech Experience is a great way for students to gain exposure to the process of science while they're in class at the high school and junior high school. So the hope is that more and more students become interested in studying science and eventually consider a science-related profession. So how can students get more exposure while they're in high school? And that's what I like to talk about now. So I have a little picture here from one of my Saturday workshops, and I'll come back to that slide later on. But could I go on to the next slide? So throughout California, there's many programs for summer enrichment at universities, colleges, and various agencies. So I'm just going to tell you about my experience at Fullerton College. I hosted 35 science summer camps to junior high and high school students to have them do more intense science projects, and also to explore various careers ranging from biotechnology, microbiology, cosmetic chemistry, food science, and more. And so even though the COVID pandemic has stopped all of these different programs throughout the state and nation, I encourage all these teachers to look for these types of programs next year. Hopefully you can do a web search for science summer camps or bridges to the biotech, and then you'll be able to find programs in your region. At the end, we'll be giving you a resource guide, and I've listed some high school internships that I've already searched. Okay, so next slide. So one of the places that you really should try to contact is your ABE Distribution Center. And several of the centers offer internships to high school and college students. So in the greater LA area, The ABE Pierce College and the Pasadena Center offers internships to, actually they're probably year-round, to several qualified students. And then Pasadena also offers Saturday production days where high school and college students come in to learn to make, not just to learn, but to actually make lab reagents. And then in San Diego, Miramar College has several programs for high school students and college students. And one of the programs is called the Supply Chain Experience, which is very similar to the supply chain project that is held at Fullerton College. So the next slide, I'll show you what happens at Fullerton. So obviously with all of these Amgen Biotech Experience Distribution Centers, we need to put together all of the lab equipment, and we have to make all the lab reagents that are then going out to the thousands of students in the high schools. And so you can see it's a very, very big job. So at Fullerton, I actually have a supply chain project where the students will come in to help to manufacture these lab reagents. So you can see, you know, we have hundreds of pipettes, we have gel electrophoresis equipment, we'll make agarose gels, we'll do 3D printing of various models. And so there's constantly work to do. So we have to clean, validate, organize, and be able to send all the equipment to the various schools. Okay, next slide. So although at the internship program we do, many of the intern students have already learned how to do certain lab skills in their classes. During the internship called the supply chain project internship, they actually come in to practice those lab skills. So we will go into the basics of how to clean, how to wash dishes, how to make solutions, use pH meters, you know, basic equipment, electronic balances, conductivity meters. And then we also have them learn aseptic technique and practice pouring sterile media, making sterile aliquots. Okay, so this is a very, very crucial skills for them to have to practice over and over. And then we also constantly need equipment and supplies to be to make sure that they work. So we do validation and troubleshooting. And basically during this entire project, students are having to practice skills that would be useful for them someday when they go into industry. So they have to do quality control, they have to do documentation, they have to understand how to follow directions and how to follow them exactly as written. So all these skills are very, very practical for them to eventually get jobs. Okay, and so most of our students come from the Amgen program. So here I'm trying to show you that for the high school students, there are some articulation. So students that are in high school biotech courses can actually articulate with colleges. And at Miramar College, they have articulation with San Diego high schools. Orange County also works with their feeder schools. But I'll speak to Orange County because that's what I know. So in Orange County, we have college faculty who go to the high schools and actually teach the college biotech courses. And then that way the high school students can get dual enrollment. And so I've had a couple of students who've actually finished the college biotech certificate before they graduate from high school. And as soon as they get that first certificate, they're eligible to come in to try to get an internship. Most of our students, though, most of the high school students in dual enrollment courses come to the community college after high school, and they will take more classes and try to get biotech certificates or biotech associates. And then we've had some students move on to transfer to the for the bachelor's program in biotechnology. And in California, there's 2 community colleges, Solano College and Mira Costa College, that offers the bachelor's degree in biotechnology. And so I've had several students go on to their programs. Okay, I have many, many more students that move on to universities and then after universities go on to graduate programs. So in my school, I happen to be at a college that has 70% minority and underserved students. And so most of my students have to work while they go to school. And by learning these biotech practical skills, they're actually much more employable. They have the skills that industry wants or the university research labs want. And so my students that take biotechnology are actually able to get internships and jobs while they're going through school. Okay. All right. Let's go on to the next slide. Okay. So here I've highlighted so all the blue dots here in Northern California and the red dots in Southern California, these are the community colleges that have had recent graduates from their biotechnology certificate or associate's programs. And so you can see most of the Northern California programs are centered around the Bay Area. And then this black dot right here is Solano College, and that is the community college that's offering the bachelor's degree in biotechnology. And then in Southern California, we have Miracosta College that offers the bachelor's degree. And so students that go to the community college for the bachelor's degree, they can earn that entire bachelor's degree for about $10,000 in tuition costs. So that's a huge savings for many of our students. And you can see here, so we have also the blue triangles on the map. So here's Miramar College, San Diego. Then this is Fullerton College in Orange County. We have Pasadena in LA, and then Pierce College in LA. And then there's a couple more, LA Trade and Mission College. These are all the Amgen Biotech Experience Distribution Centers in Southern California. Sorry, I think I forgot Mount San Jacinto in Riverside. Okay, so I'll go to the next slide. So I just wanted to show you, I'm from one college, and when I was looking through my pictures, I found this picture from October 2015. So this is one of the Saturday production days or the skills workshops that I used to run. And because many of the students have come to me for mentoring, for attending the Saturday workshops, coming to the summer camps, come to the internships, they still send me notes about their educational and career progress. And so, so from this one picture, I noticed that I still keep in touch with many of them. And so I've listed some of the degrees that they've already attained, and then their current, you know, where they are currently. So many of them, you can see, already have earned bachelor's degrees in a science field. And then some of them have gone on to PhD programs at Riverside, Caltech, UCLA, and then others have gone on to professional schools in healthcare. So this is a physician assistant, here's BetMet. And then I have others that have gone on to work in the industry. So here's one and here's another one. So anyway, I just keep in mind, this is from one Saturday workshop at my one college. And so if you see how this Amgen Biotech program can actually partner to so many different colleges, the impact is incredible. So it's been amazing to see the progress of these students from my college. And I think it's truly important that we keep stimulating students when they're young. We encourage them to get more exposures about lots of different careers and provide ways for them to gain practical lab skills that will help to lead them to good jobs. So anyway, so next slide, let's see. So anyway, so if you would like to get involved in the Amgen Biotech Experience, this is our main website that's called the Amgen Biotech Experience.com. And then here are the links to Maya, Lauren, and myself. And we put together a list of resources that should be in your Whova resource page. It will give you the PowerPoint handout, as well as the links to each of us, and also links to, I've also compiled a list of internships for high school students in California. So you might take a look at that. Okay.
All right, and then last, we just want to say thank you to everybody that comes together to make this possible. This is a huge team effort. Thank you especially to the Amgen Foundation, which, as I mentioned in the beginning, this whole program is made possible because of the Amgen Foundation. And then in Southern California, at San Diego, we've got Biocom Institute, Miramar College, and Mount San Jacinto. That's our team down here. Maya and her team are all of ABE San Francisco at the Lawrence Hall of Science at UC Berkeley. And then the LA Promise Fund in LA partners with all of these institutions, LA Pierce College, LA Mission College, LA Trade Tech College, Cal State Channel Islands, Pasadena Bio, and Fullerton College. So a huge thank you to everybody that works to make this program what it is. And with that, we will take questions, and I will stop sharing so we can all see everybody.
Okay, so first question is, are we planning an on-site ABE training in LA this summer since most were canceled in late 2020 and early 2021?
I think we're still talking about it, so we will let you know. So if someone is interested, just please contact us and we can let you know. So right now we don't know.
Okay, I think that's kind of the norm right now for everyone. So speaking of the norm, somebody has asked, are these techniques industry norm and how are they vetted?
That's a really good question. I'm not sure, Joe, industry norm, that's kind of an interesting, like, I don't know that you have an industry norm for pipetting. That seems like just a skill.
Well, so can I address that? So there is actually a micropipetting challenge every single year that's actually sponsored by the Artel calibration service. And so we, in Orange County, we actually offer a pipette challenge. And it's a competition that everybody comes in and they have to pipette, and the calibration spectrophotometer goes like, I don't know, four absorbance units or something. And so we can actually tell if the students are very, very good at pipetting. I will say that in LA area, the community colleges have been working on a California biotech assessment to test the biotechnology theory knowledge of students. And so there is still talk about the digital batching of various techniques. Yeah.
I think there was a question about vetting. I was just going to mention that the Amgen Biotech Experience curriculum is something that was originally developed by Professor Marty Wu out of the LA area. I think Marty was originally at Fullerton, right?
Marty Akanda, it was out of Pierce College.
He was out of Pierce, okay, thank you. But it has since been revised, and that aspect of the program has been vetted by curriculum experts across the country at different institutions. And the techniques are things that, I don't know if this counts as vetting, but when I have guest scientists come from Amgen to talk with my teachers at trainings and various other things, they're always saying, oh yeah, I did that yesterday. Exactly what you just did in lab this morning while I was waiting to give my talk. That's what I did yesterday. So there's some vetting for you.
Right. And I'm actually on the, we're on a committee, so there's multiple community college faculty. They're through the state that are working with industry partners to set up guidelines for the supply chain projects so that we can make sure that students are understanding what type of industry documentation that they should be practicing, what kind of good lab practice, good manufacturing practices they should be practicing.
And speaking also to the industry relevance, one of the aspects of this program is that ABE wants to give research grade equipment to students. And so that is what we offer. Although interestingly, I often have teachers that are like, this equipment is huge. Is there not like a classroom compatible alternative? So we do have some like education grade electrophoresis units for the teachers that don't want the big honkers that are used in a research setting. But I mean, it is research level equipment, and the techniques that they're practicing are definitely applicable, any type of like wet lab skills that students would need to do in a real research setting. And I also just want to mention with that industry connection that a lot of us, I think all of us, partner industry visits with this program. So we'll try to provide opportunities where students can go to an actual Amgen lab and see what they've done in their classroom. What does that look like when it's scaled up on an industrial level? And where they grew a tiny little beaker of fluorescent bacteria, what does it look like to have these giant vats of bacteria growing for industry to actually purify, real treatments, real medical treatments? So that's another aspect of the program that we didn't mention.
Okay, well, we have another question. In underserved communities, have there been any programs where the universities and colleges go into the high school to do the science program?
I can talk a little bit about this with San Diego. So when the program started in San Diego back in the early 2000s, that is something that was a strong component. And the reality of what happened as the program grew is we just didn't have the bandwidth to keep going into classrooms and help supporting with the actual instruction. And while that component of it is unlikely to return, we are piloting a program with a Title I school, Helix High School, who also has a session at the Life Science XP Symposium. But we're going to be using our pilot with them this year to inform some more support that we can provide to Title I and lower income schools so that they are getting some more personalized support, because it is a big lift for teachers to implement this curriculum. You know, we provide all the support we possibly can, but at the end of the day, it is still the teachers in there rolling this out with their students, kind of in the trenches, making sure that the experiments are working. So we're definitely exploring ways to more sustainably provide that kind of support on a larger scale.
So I'll speak for LA. So the Amgen LA Distribution Center site coordinators do go out to various high schools that request for them to come out and help. And for Fullerton, maybe because I have those college internships or college interns, I try to recruit students who are very good at communication and understand about technology. And so they go out to the high schools and they can actually help out with the high schools. And my lab technician also definitely helps with students or teachers that request. And so I'm hoping that is the sustainability component, is that if we have student interns that are partnering with the Amgen Biotech program, that they are continuing to be able to service future teachers.
And I know that in Northern California, another thing that we've done is we have a few districts, well, we have more than a few districts that have underserved students, but in some of the districts that have larger populations of underserved students, we've done specific partnerships with that district where we go and do sort of extra professional development with the teachers there. So they get more support that way. And some of the districts have set it up so that they have a teacher who is sort of the ABE champion, if you will, that also gives the other teachers in their district extra support. Since Lauren mentioned it's me and one other person up at Berkeley serving everybody, so we can't get into the classroom, even though it would be fun. We have set up some other avenues to help support those teachers in particular that are at those underserved schools.
Great, okay, thank you. We've got a couple more questions. Is computational biology integrated into this curriculum?
It is not in the strict sense of what computational biology is. It's not trying to cover everything. It's a 2 to 3 week unit. So you could certainly do an extension with computational biology or a number of extensions with computational biology, but it's not in the strict curriculum itself.
And I would venture to guess that if you were interested in incorporating computational biology, you could probably reach out to your distribution site and they could explain to you how to use things like NCBI's BLAST and provide you with the RFP sequence so that you could do some kind of basic bioinformatic work complementing the ABE curriculum.
So there is an advanced ABE lab for personalized medicine. And so we have definitely offered teacher professional development about bioinformatics and how they could incorporate that into the program. But that is not our typical beginning training to our teachers.
Great, well, we are at time, but let's just ask one last. You mentioned dual enrollment and articulation. How can my students college credit for ABE?
So contact your fellow or your local college faculty. If you're in Orange County, contact me and I will help you with the process. And maybe Lauren and Maya can speak about the other regions.
Yeah, if you're in San Diego or Mount San Jacinto region, just contact me and I can put you in contact with the appropriate person.
Great.
And I don't think we have any articulation programs that are specific to ABE, but I know there are some in the Bay Area. So yeah, reach out and I'll see what I can do.
Excellent. Thank you. Well, thank you all, Lauren, Joe, and Maya. We appreciate your time. This has been a really informative presentation, and I'm glad you provided those resources for us. So, everyone, I hope you join us for a networking session, and we'll see you soon.
Thanks, Karen. Thanks, everybody.